All right, guys, I want to go over the Unit 5 test review really quickly in case you weren't able to make it to the live review session, or if you were in there and you were having a hard time following along with the solutions I was working through. I wanted everybody to have an opportunity to look at the solutions before you take the test. So let's go over number 1 really quickly. So number 1 says if sine of theta is 3/5 and cosine of theta is 4/5, then what is tangent of theta? So one thing that I think a lot of people were confused on with this question, or with questions like this, was it kind of looks like those questions that you might have done on the trig identities IXL, or on the Khan Academy where you're using the Pythagorean identities. It would say something like if 0 is less than theta is less than 90 degrees, and sine theta equals 3/5, what is cosine of theta? And so these are the questions where you would have to use the Pythagorean identity. So remember that sine squared theta plus cosine squared theta equals 1. So you could solve this equation, or solve for cosine theta here using the Pythagorean identity, sine squared plus cosine equals 1. But this is a different type of question, and we know that because there's no Pythagorean identity that relates sine, cosine, and tangent. So I don't have an equation that I can just plug these three into that would give me what tangent of theta is. So these kind of look like similar questions, but they're actually asking you to do different things. So for this one, what we're doing is we're just trying to find out what tangent of theta is given these two facts about the angle theta. So what I'm going to do, what I like to do with this type of question is just draw a triangle. So I'm going to draw a triangle. I'm going to label this angle theta. It's a right triangle. It doesn't have to, I could label this angle theta. It doesn't really matter as long as I am consistent when I'm labeling the sides here in a second. I just prefer conventionally to use the lower corner angle, but either way works. So I know that from my SOHCAHTOA rules that the sine of an angle is equal to the opposite side over the hypotenuse. So the opposite side, that means that if the sine of this angle is 3/5, that means the opposite side then is 3. So the opposite side from angle theta, directly across from it, it doesn't touch, is 3. And that means the hypotenuse then is 5, right? Opposite over hypotenuse, that means my hypotenuse is 5. That's the longest side directly across from the 90-degree angle. So that gives me 2 of the 3 sides of this triangle, but my cosine information is going to give me the other side. So I know also that the cosine of an angle is equal to the adjacent over the hypotenuse. So the adjacent over the hypotenuse. So that means that my 4 is going to be the adjacent side, and 5 will still be the hypotenuse. So that should make sense, right? Because we should have the same hypotenuse for both of these. We're looking at one triangle. It should have the same hypotenuse. So it makes sense that 5 and 5 match up there. And that tells me that 4 is the adjacent side. So the one that touches my angle, but it is not the hypotenuse. It's the other side that touches my angle. So I've labeled all 3 sides of this triangle. Now the last step is to remember the tangent is equal to the opposite over the adjacent side. So tangent of theta equals opposite over adjacent. So now my last step is just to fill in the opposite side and the adjacent side from the triangle that I just drew. So the opposite side would be 3 and the adjacent side would be 4. So that tells me that the tangent of theta is 3/4. So that's true because I know that the cosine and sine are 4/5 and 3/5. So yeah, strategy for that one is typically to just draw a triangle, fill in the side information that you know. You might be able to just look at this and see, okay, this is opposite, this is adjacent. So I just do 3/4. Personally, I like to draw the triangle, especially sometimes these won't be round numbers. But again, it's up to you as long as you can see the relationship there. All right, let's look at number 2 really quickly. So number 2 is giving you 3 points and is telling me that they make a right triangle. So I'm gonna plot those 3 points just to verify. So the points they give me are A, which is -1, 0, B, which is -1, 5, 1, 2, 3, 4, 5, and point C, which is 11, 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's point C. And it says this makes the right triangle, and it looks like it does. So I'm going to go ahead and draw that. And even if it didn't tell me this was a right triangle, I know that this side is on the x-axis, so that's a perfectly horizontal line, and I know that this is a perfectly vertical line. It goes from the point -1, 0 to -1, 5. So I know that these two have to be perpendicular, so they have to create a right triangle here. So I'm just going to redraw this triangle over here to make it easier to see. All right, I know it's a right triangle. This is point B, point A, and point C. And so what they're asking me for is the sine of angle ACB. And so this is what I think some people got confused on. Remember that if they're labeling an angle ACB, that means the angle that I make when I go from A to C and then from C to B. So A to C to B makes this angle right here. So in other words, it's labeling the angle at the letter that's in the middle. So the angle at point C is the angle that we're looking for. So I'm going to label that theta. So that's the angle that we are dealing with. Sine of angle ACB means the sine of this angle down here. And that's just a convention from geometry. When you're labeling an angle, you always label it with the point of the angle or the vertex of the angle at the letter in the center. All right, so we know which angle we're looking for. We know we're looking for the sine of this angle. Sine, we know, is the opposite side over the hypotenuse. So at some point I'm going to need to figure out what the opposite side is and what the hypotenuse is. Let's see if we know any of that already. So if we go back to our triangle here, we know the length of this side, AB, is just 5 because we go from -1, 0 to -1, 5. So we just go up 5. And here we know that from the origin to point C is 11 units. And then we also know that from the origin to point A is -1 units, or a distance of 1 unit. So if we add those two together, we end up with a side length of 12 for side AC. So we've got 12 and 5. But I don't have my hypotenuse, so I still need a hypotenuse in order to solve for the sine. So what I'm going to do is just my Pythagorean theorem, because since this is a right triangle, I can say that 5 squared plus 12 squared has to equal, I'm going to label this C, C squared. Actually, C is kind of confusing because there's a point C. I'll just label this X is equal to X squared. So this is going to be 25 plus 144 equals X squared. And that means 25 plus 144 is 169, I believe. And I know that this is a perfect Pythagorean triple is what we call it. So 5, 12, 13 is what we call a perfect Pythagorean triple. So it's basically 3 round numbers that satisfy the Pythagorean theorem. So I know that my hypotenuse is going to be 13. That's the square root of 169. So you can check that in your calculator if you don't believe me. So there's side length 13. So that's my hypotenuse. So the last step to find the sine of this angle down here is just to write it as the opposite side over the hypotenuse. So sine of theta is equal to the opposite side, which is 5, over the adjacent side, over the hypotenuse, which is 13. And usually the question will ask you to leave it as a fraction. If it didn't, you could leave it as a fraction, or you could put that in your calculator, 5 divided by 13, and put the decimal if you wanted to. But that's that one. So the hardest part, I think, of that was just identifying which angle. I think most of you could draw this triangle pretty easily from the points that they gave. And then just remember that to find the sine, you're going to need you're going to need the opposite side and the hypotenuse. All right, let's look at this one really quickly. So this one's asking you to use the law of cosine. So we're lucky here that it tells us to use the law of cosines. Sometimes they'll just give you a triangle and tell you to find x, and they don't tell you how to do it at all. But we know that this is either going to be the law of sines or the law of cosines because this is not a right triangle. So since I have an angle of 114 right here, and I know that all of my angles in this triangle have to add up to 180 total. There's no way that I can get a right angle, a 90-degree angle, and still have these add up to 180. 114 plus 90 would give me 204, I think. So that's going to be greater than 180. So there's no way I could get a right triangle out of this. That means I'm either going to use the law of cosines or the law of sines. And in this case, they told me to use the law of cosines, which is helpful. I think generally on the test, that's probably the case. I don't think I'm going to give you any that require you to identify which one to use, but you should be able to do that. If not, just use some trial and error. Try the law of cosines. If you can't figure out a way to make it work, maybe it's the law of sines. But generally, if we have two sides and an angle in the middle here, and we're looking for the third side, we can use the law of cosine. So the first thing I need to do is label the sides of this triangle. So I'm going to label them A, B, and C. And it doesn't really matter which ones I label as which, as long as I'm consistent in this next part. And the next part means if I have side A right here, that means the angle A, capital A, has to be directly across from it. So that means that this 114-degree angle has to be capital A because it's directly across from the side that I labeled A. And that means that this has to be angle B, and this has to be angle C. So as long as you're consistent, it wouldn't really matter how you labeled these, but the angle and the side have to be directly across from each other in order for these formulas to work. So the next piece is, I know that I'm looking for side A. So A is what I want to find. And I have B, C, and angle A. So I don't have any other angles. So that's a pretty good clue that I don't really want to use this second equation or this third equation because they require me to know what angle B or angle C is in order to find some other piece. So that's a pretty good clue that I'm going to use this first equation, and it's actually already solved for me in terms of A. A is already by itself over here, side A. So all I'm going to do is just plug in this other information that they gave. So I'm going to plug in that A squared is equal to, so B is 28, so 28 squared plus C, which is 17 squared, minus 2 times B, which was 28, times C, which is 17, times the cosine of angle A, which is 114 degrees. So I'm solving for A squared here. So all I'm going to do is just plug all of this into a calculator. And it's a lot, but in this case, it's pretty easy because I don't have to solve this algebraically. I don't have to do anything else. I just have to, A is already by itself over here. So all I have to do is just plug this into a calculator. Let's do that really quickly. Oh no. I think I did it earlier. This is from the live review. But so we're going to do 28 squared plus 17 squared minus 2 times 28 times 17 times the cosine of 114. So I'm going to plug that in. Now, one thing I need to make sure of is that my calculator is in degree mode, and it is. But if you were in the live review, remember that it wasn't at first, so we got a weird answer. So make sure you're in degree mode. And so this is equal to A squared. So A squared is 1,460 roughly. So 1,460. So that means that A, to find A, I have to take the square root of both sides. So A is actually going to be the square root of that. Let's do, so that is 38, roughly 38.2, we'll say. So A is 38.2. And there's no units on this, so just leave it as 38.2. But that's it for that question. All you're doing is plugging into the law of cosines and solving for A. Sometimes they might give you C and A and ask you to find B. And so if that was the case, given angle A, that means that you might have to plug in A, C, and angle A and solve this equation for B. So that's going to be a little more involved, a little more complicated. It may not always be as straightforward as just plugging in numbers and then taking the square root. But in this case, it was pretty straightforward. All we had to do was plug in and solve for A. And then this last one, so this one I think is confusing to people just because there's no numbers involved. So this is actually getting you to look for the trig identities that you've learned. So this is one of the trig identities that was on Khan Academy. And it's also on your trig cheat sheet, which you'll have available during the test. Let me go pull that up. I thought I had it pulled up already, but maybe not. It's labeled trig cheat sheet on your Google Classroom page. So I'm going to go right down here to the even and odd formulas. So tangent of negative theta is equal to negative tangent of theta. So basically these two things are equivalent. The Khan Academy video goes through why that is. I'm running out of time, so I'm not going to go through that here. But this is equal to negative tangent of theta. That's all that was asking you to do is go find your trig cheat sheet. I wouldn't expect you to have that memorized necessarily, but it's pretty easy to go access that information. So that's the review. If you have any questions, let me know, and thanks for watching.